Here is another video. We'll try to find the diagonals for 3D figures, application of Pythagorean theorem in all kinds of shapes which you may see in your textbook or in any exam. Follow our series to get the complete details. Enjoy learning with Anil Kumar. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have taken up application questions based on Pythagorean theorem. So these are all 3D application questions. We'll consider cuboids, we'll consider a square prism and a square pyramid combination, and also a wedge to find diagonal lengths using Pythagorean theorem. Let me first thank all the viewers and subscribers for watching my videos, posting excellent comments and suggestions. Our videos are complete in the sense that we cover the topic in total depth and with many examples. So if you follow us, you are destined for success. Let me also thank you for your comments and suggestions, and especially the contributions. You know, we have been serving you for last 15 years absolutely free. Now, we have 17,000 videos almost every day. We are uploading a video for you answering your own question. I hope that really helps. It is your channel. Help us to contribute, right? Thanks a lot for all your contribution. Now, let's begin with the solution of this question set. So we have a couple of questions based on all the figures you see. We'll begin with a very simple structure, which is cube. The question here for you is a cube 8 centimeter long on each side is an open top box. Find the length e to g. So this is the cube, and what length you need to find e to g is this. Find the length e to g. Find the length of the longest rod that can be placed in the cube. So have a good look at this particular cube. Each side is 8 centimeters long. You need to find the length of the longest rod, which could be along this particular path. Now, you can pause the video, answer the question, and then look into my suggestions. These questions should be answered without calculator. However, you are free to use calculator also. So let's begin by finding the dimension e to g. As you know, the base is a square, so every angle will be a right angle triangle. So we have a right angle at h, and that means the sides which are 8 each, you can see, form a right angle triangle, and therefore e to g square should be equal to e to h square plus h to g square, correct? And clearly we can find the diagonal square by writing 8 for the given dimensions, and as you know 8 square is 64, so you can add 64s and then what you get is 128. So e to g is equal to square root of 128. So if you calculate with a calculator, you get a decimal value. However, we can also get 8 square root 2 for this, right? 8 square root 2. Okay, so that becomes perfect answer, and the units will be centimeters, right? So if I use calculator and write decimal value, it will be square root of 128, which is in decimal equal to 11.31. So we can approximately write this as 11.3 centimeters. So we are going to write all our answers to one decimal place. Is that clear to you, right? Okay, now let's try to answer part B of this, which is the longest rod. Now clearly in this, the longest rod will be from E to C, right? So that is going to be the longest rod. Let me put a highlighter there along this particular path. Now, how do we find that dimension? Well, we know each side is 8, right? We just found what is e to g, right? Which is 8 square root 2. And therefore, we can now use this particular triangle. We know that the triangle EGC is a right triangle, correct? And therefore, e to c square should be equal to square of e to g, right? And plus the square of c to g. And that gives you 8 square root 2 square plus 8 square, right? So that gives you, we have three eights now, right? So if you kind of work it out, what you get here is 8 square times 2 plus 1, 3, right? So we get 8 square times 3 within the brackets, right? There are 3 8 squares here. So EC will be equal to square root of 8 square times 3, which is 8 square root 3. The decimal value will be, you can add 128 and 64, right? And then you can find the square root of this number, getting the answer to the decimal places 13.85, so which can be approximately to 13.9 centimeters. You get the idea. Now, one more thing which you need to understand here is that if I find the longest side, it basically equals to a square plus b square plus c square, right? We'll take this up in the next question. I hope you have understood how do we solve a cube, and in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Now, let's look into the next example where we have taken a prism. So here we are given a prism whose sides, which is also called a cuboid, which is 22.5 centimeters by 30 centimeters by 40 centimeters as shown here. We need to find the length e to g. Let me e to g, right? And then we have to find the length e to b. E to b is in this plane. Okay, and then we have to find the length e to c. So from e to this. Okay, so these are the three lengths which we need to figure it out. So let's figure out what is e to g equals to. Well, using Pythagorean theorem, because we have a right angle triangle right there on the top and dimensions are 22.5, we'll square this plus the other dimension is 30 centimeters, we'll square that and we'll later do the square root, right? Let's first square and add. So we have 22.5 square plus 30 square, and that gives us a value which is 1406.25, and e to g will be equal to square root of 1406.25, which is equal to square root of this answer is equal to 37.5. 37.5, and the units are in centimeters. So you see, we have found e to g, right? Now let's figure out what is e to b. Now to find e to b, we are looking at this particular triangle, correct? Right. So in this triangle, what are the dimensions? Well, the dimensions are 40 and 22.5. You can use these dimensions and find the answer, correct? So I'll do a short form here for you. E to g, e to b, sorry. E to b should be equal to square root of 22.5 square plus the height is 40, correct? This side is 40, correct? And this is the right angle triangle which we are looking at, 40 square. So 22.5 square plus 40 square should give you what? It gives you 81,000, and square root of this answer gives you 900. So this is actually 900. So we get this dimension as 900, And now we know this is 900, correct? The units being centimeter, and the other one here is 37.5 centimeters. Now let's find what is EC in the next example. Now, E to C is this particular dimension, right? E to C. So let's highlight this E to C. To figure this out, what should we do? Well, a couple of things. We could use this diagonal and this height, correct? Knowing that that is right angle triangle. Now this triangle A to C is same as E to G. Do you see that? So E to G we figure out in the last case as 37.5. So this is 37.5. So this is also 37.5 in the bottom because of the shape, right? And 40 is the height. So basically, we find E to C square is equal to 37.5 square plus 40 square, correct? And E to C will be square root of 37.5 square plus 40 square. And we can find out this answer using the calculator. 37.5 square plus 40 square gives us a big number, and we are going to divide this, find the square root of this, right, and get our answer, which is equal to, in decimals, 54.82. So I'll write this as 54.8 as our answer, and the unit being centimeters. So I think you understood the method. You need to use calculator, verify the result. Well, in case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Now let's move forward, take more examples. This time we have a pyramid. After that, we are looking into pyramid on top of a cuboid and then into a wedge. So three more types of examples which should complete all the examples which you are expected to know for any exam on using Pythagorean theorem for 3D shapes. So let's continue with the pyramid. PQRS is a square based pyramid with the vertex V. Pyramid is 8 by 8, so these dimensions are 8 by 8, and this height is given to us as 12. Okay, so let me write down 12 here. Find the length S to Q. So S to Q is the diagonal of the base, and clearly S to Q should be what? The two squares, sides are 8 and 8, so SQ should be equal to 8 square plus 8 square square root, right? By now, you should know it should be 8 square root 2, the exact value, and the units being centimeters. Is that clear to you, right? Verify your results. Now, the part B is if M is the midpoint of RQ, find the length VM. So, which is the length VM? M is the midpoint, so we'll just join midpoint with the center, and we need to find the length V to M, correct? And that is the right angle triangle we're looking at. We are given that the height of this is 12. How will you find it? Well, Vm square is definitely equal to Vg square plus Gm square, right? Now, V to G square is 12. So we have 12 square and G to M is half of 8, right? So we can write this as 4 square. So we have 144 plus 16 as Vm square, right? So Vm is equal to square root of 144 plus 16, correct? So which is equal to, so if you add 6, we get 10, and then 60, 160 square root, which can be simplified, and you can get the answer as square root of 160. Perfect. So I hope the concept is clear to you, right? Now, so let's do the square root of 160. What do you get? We could get 16 times 10, right? Which will give you 4 square root 10. The decimal equivalent for this is 12.649. So I could write this as 12.6 as the estimated answer, units being centimeter. Is that clear to you? So we have now solved a square based prism pyramid, and in the pyramid we found the slant height, right? Now that can help you to find area of each of these triangles. So this question can be really extended to find the surface area for other students, right? So we can extend this to find surface area. Find surface area, right? Okay. Now, I hope the concepts are absolutely clear. Feel free to write or comment, share your views, and if you want, you can also contribute to our channel. Right. Let's move on to the next question, which is kind of complicated. We have a pyramid on top of a prism, a cuboid, right? The question here is that given a square based prism with square pyramid on top of it, the prism is 6 centimeter by 6 centimeter by 4. So these are two 6 centimeter, 6 meters, sorry, 6 meter long, and 40 meters is this height, right? The slant height is 10, so each side is 10 for us. Part A is find the length AC and the length AG. So there are two lengths, A to C, which is right there in the base. So AC is very clear, is equal to square root of 6 square plus 6 square, right? So you can say 6 is square is common, 1 plus 1, right? That is how we were getting square root 2. And that gives you 6 square root 2. You can always use calculator to find the answer in decimal values if required to one decimal place. So it gives you approximately 8.5 and the units being meters. Is that clear to you? So we've done AC. Now let's do A to G. A to G is from here to there, right? So it's a long diagonal. Now remember this, that this is A to G is equals to square root of 6 square, 6 square, and 40 squares, right? So that is a shortcut which you could use in such a case. So that gives you 36 plus 36 plus 1600, right? Square root. And we can figure this out. So we got 36 plus 36 plus 1600, and that gives you 1672, and the square root of our answer is in decimals equal to 40.9 approximately. So we get this length of 40.9. So let me write the length as 8.5 meters and 40.9 meters. Correct. Now let's do part B on a separate page. The part B is to find the shortest distance from O to FG. Now, point O is given to us. This is FG. The shortest distance is the perpendicular, right? So that's the altitude of this triangular face of our prism. Now, how do we find that? Clearly, we know one side is 10, and since this is 6, half of this should be 3. So we're looking at the triangle, right? So let this be the midpoint. In that case, O to M is square root of 10 square, right, which is the hypotenuse, minus 3 square, right? So that is square root of 100 minus 9. So we can use the calculator, 100 minus 9, and find the square root of this particular answer, rounding it, which is square root 91, of course. So this is square root of 91. And rounding this, we get 9.53. So 9.5 meters becomes the answer. So that becomes the altitude of this triangular face. So I hope by now you've learned many concepts. We have done cuboid with combination of prisms. Now the last question here is to work on wedge. Now wedge is very tricky. So I like you to kind of think and recollect what you have learned. Okay, so we are given a square based wedge. That means these two sides are same with a height of 5 meters as shown here, right? So square base 12 by 12, this is 12 by 12. Find the length A to F. Now A to F is this particular length, right? So we can easily find A to F as equal to square root of being hypotenuse 12 square plus 5 square, right? So that gives you 144 plus 25, or gives you square root of 169, which is indeed 13 exact value. So we got this as 13. Perfect. Now, AF is 13 for us. Find the length A to M. That is where M is the midpoint of EF. So now we need to find A to M, right? So this is kind of a diagonal, right? Now, A to M. Now we can draw a perpendicular from here. Now, can you see the construction? While clearly what you're looking at is we need to draw from here up to this point also, and then we have a right angle to work out. Perfect. So I'd like you to try this question out, right? And then look into my solution. So once again, what we have here is we need to find A to M, right? A to M, we can draw a perpendicular and find what is A to perpendicular distance here. So let's call this point as n, which will be 10 units, right? So let's first find A to n. So A to n being, this is a right angle triangle here. So sides being 12 and so 12 by 12 this is, right? This is again 12 centimeters. So 12 by 12. So basically this point is 6 units here, right? So we have 12 and 6, correct? Because I wrote base as a square base, right? 12 by 12. So I'll change this to 12 for now. Is it okay? So in that case, this will be 6 centimeters. All right. In the figure, it was written as 20, correct? So basically, let me change this to 12 centimeters and then solve it. So this will be 6 and this will also be 6, correct? So that is what we are doing. We're trying to find A to N. Right. So A to N is 12 square plus 6 square square root, which is 144 plus 36 square root, right? So that is how we'll find this. And now we'll find A to M. A to M, now 5 is this height, so we have to find A to M. So clearly A to M will be square of this, which will be 144 plus 36 plus 5 square, right? So which is 144 plus 36 plus 25, and then we can find A to M, right? So these are very friendly numbers to work with. So we have 144 plus 36 plus 25, that gives you 205, and the square root of this is, so we can write the decimal value of AM, which is square root of 205. 14.31, I write this as 14.3, the units being centimeters. So I hope with this you have understood how do we solve 3D figures, right? All the type of diagonals which we learn. Now these are the type of questions which you normally get. So I hope you have understood the complete process of using Pythagorean theorem for 3D shapes. So we found all the kinds of diagonals, including the longest diagonals in the given figure. I hope it works for you. Thanks a lot for watching my videos and your contributions. Thank you and have a great day.